All right, folks. I had already recorded this video because I always post everything by Wednesday. But after Friday's class, I wanted to come back and remake this video and add some additional insights that I think will help you as you work your way through assignment 7. So assignment 7 builds on some of the things that we've done in class, and it asks you to go a little bit beyond it. Our goal this week is to get to trend estimates for 288 sites in this analysis. So it's a big lift. Again, this is not a coding class. This is a hydrology class where we use coding. So you're following along with this video to explain to you why we're doing what we're doing and how we're setting it up. There's a reason we don't have exams. There's a reason that I'm not quizzing you on writing code. It's because a lot of you are seeing this for the first time, and I'm cueing you how we would do this in a research context or in the consulting world. So assignment 7, I'm going to bring it up here. I ask you from Wednesday's class to either calculate the Richards-Baker flashiness index or to use the interp1 function to estimate the 5th and 95th exceedance percentile values. So that is something you want to do before you start this video. Again, Friday's class, we use the polyfit function to estimate a trend in the base flow index, something you should have done before you do this video. I have a video posted for that Friday class if you'd like to revisit that. And then something else I want you to do again before you're starting this video is identify which signatures you're going to focus on for project 2. You have to pick out 2 metrics that we're calculating from the hydrograph. They can be anything. I talked to, I think, nearly everybody in class on Friday about what they were going to pick. And again, as a reminder, I would encourage you to find a group of 2 or 3 people that are looking at similar values, because you might want to talk to them about your code. You might want to talk to them about your results. This is all tied to and in the context of climate change. So if you're interested in snow, maybe you're curious about how summer stream flow is going to change. If you're really interested in evapotranspiration, maybe you're thinking about low flows. I am happy to talk to you about this. And the goal is for you to pick something you think is interesting. So your goal is, again, to write your code for these signatures in your annual loop. If you run into issues, again, please come see me. I am happy to help. Once you have done that, you are here. You are following along with this video, and we are going to do something crazy today. We're going to go from having your code run for 1 site to having your code run for many, many, many sites. Again, this isn't something I expect you to know how to do. That's why there is a video, and that's why you're following along and we're talking about it. So on Moodle, you are going to go to our CE352 folder and our project 2 Streamflow. So there's a bunch of information here, but what we want is this project 2 time series at all sites. Go ahead and click on that, and it's going to appear as a big folder. And as a reminder, if you're not on a Mac, you can just delete that folder or ignore that folder. You're going to go up here, you're going to say download, and it's going to say, are you sure you want to download it? It's really big, and you're going to say yes. And while you wait for it to download, I'd encourage you to plug in your drive if you haven't already. Mine is already plugged in. So as that downloads, you can see it's almost there. It's telling me it's done. I am going to go over and go to my downloads folder, and there it is up at the top, project 2 site data. I'm going to copy it. I'm going to navigate to my drive, my 352 folder, project 2, time series. I had a time series folder. Maybe you do, maybe you don't. And I'm going to paste it in there. And mine says replace because I've done this a few times. That's okay. So now I have my zipped folder in there. If you're on a Mac, all you got to do is double click. If you are on a Windows PC, you're going to have to extract the information from that folder. And I'm just showing you, right, the evolution of all of my code. I keep it all in one place because it is referencing the same files And if you move it to a different folder, it doesn't know where to look for those other files. I am going to go in this folder now, and I am going to select all of the values, and I'm just going to drag them out to my main folder because I want them in that same folder where MATLAB can see everything. And I'm going to just delete that folder right now. All right, so I have 288 sites. That's insane. I'm going to navigate to my latest code, which I would encourage you to do too. And I'm going to open MATLAB. I already have MATLAB open. And I'm going to open that latest code. I'm going to need to say, actually, I'm going to navigate out here. I'm going to say, go to my drive, my CE352 folder, my project 2 time series. And I'm going to say open. And again, I should see my M files. I should see all of my CSV files that I've just downloaded. You already had site 1. We just added everything else. And I'm going to open my most recent MATLAB file. And in this MATLAB file, as a reminder, you've got a file name at the top. You've got a import code that brings your data in. You've got values to pull out all of the water year, the starts and the ends of the water year. And then we loop through the water year and calculate each of your signatures. So if you're calculating additional signatures, like RBFI or Q5 and 95, hopefully you have those done. But if you're doing a maximum, right, a max Q, you're going to still put everything in a loop, right? We are applying our maximum to our annual hydrograph, and we're just pulling out the maximum Q. So we can do that for any signature, and the hope is that you will have already done that by the time you're following along with this video. I also told you in class to write your code as 1, I instead of I, 1, and you're going to see why that is now. All this does is it's putting it in the first row, and then in each column, we're filling in an annual value of base flow index. All right, so let's start doing the crazy things. We are going to add a second loop. So stay with me. The information that you have down below that you made for the entire time series, we don't really need. I'm just going to comment it out. You can leave it there. It doesn't matter. And I'm going to scroll up here, and above file name, I'm adding another loop. I'm going to say, I can't say I, but let's say for K equals 1 to 288. Why 288? It's because we have 288 sites. And then I'm going to come down to the bottom at my trend, and I'm going to say end. And then I'm going to select all of my code. I'm going to right click on it, and I am going to say, oh, where is it? Smart indent. I like this because it helps me see what is happening. For each site, K equals 1, K equals 2, we're going to load data. We're going to bring that data in. We're going to find each water year. And then for each water year at each site, we're going to calculate all the values. Then we step out of that and say, just for each site, we want to pull out the trend in a metric you're interested in. So we got to change some things. We got to change our file name. I'm going to zoom in a little bit, hopefully, so you can see this better. So this is only set to 1. And again, it's purple because MATLAB knows it's text. We are going to add straight brackets around the outside. And I am going to split up where the 1 was. Then I'm going to use a code or a function called num2str. What this does, let's see if we'll read about it again, if it pops up. Oh, it's just telling you what to do. But in this case, it is turning a number into what we call a string or a character, basically that purple stuff. So we want to say for each site, for each K, take that value and just find the file name. And again, just watch what I'm doing. I'm going to test this out. I'm going to say, let's say K equals 1. And I'm going to come over here and copy this code and paste it into my command window. And it looks like it works. Let's pretend K is equal to 200. And let's verify that this also works. This also works. So now we have just generalized our file name. And what this should do is load in each file over here and pull in the data and run my code. But there's some other small things I need to do first to make sure everything saves. Now I don't just have I have K. Again, I don't expect you to know this. I am showing this to you because this is how we can process a lot of data really fast. If you tried to do this in Excel, you would be in pain. I am going to scroll down here and I'm going to go to whatever signatures I have, BFI year, any others. And I am going to index each one on the left side, right? I'm telling it where to save the values on the right side. I'm going to say use K first. That's going to put each set of data for one site in each row. I is on the right, meaning that that value will go into columns. The other thing I'm going to do, you're going to scroll down here and I'm going to show you how this works. For trend BFI, we want to save that as K, 1. If you were to do your trends for any other metric, again, you can use the same code. You can use this exact same code. Let's say you have a maximum Q. So let's do Q max. I would need my Q max code up here. I'm just going to write it real fast. Max Q. Same thing, K, I. It's my maximum of each water year. I can update this to max Q. And then I would want to name each one of my components so it's saving separately and I know what it is. So my trends I now have for BFI and any other signature. And again, you can duplicate all of this stuff. You have a framework that you can put things into. All right. So the last thing I need to do on my line where I'm running my polyfit, right now, it either doesn't have any information or is just grabbing the first row. I want to tell it to grab each row as my site numbers change. So any values you have in there should point to K. I'm going to leave this here for a second. Go ahead and pause it if you need to. And we're going to talk through, I'm going to show you what is happening. So MATLAB has these debugging commands, and I want to use them to show you what is happening in this loop. So what I'm going to do is I'm going to put a little stop sign there, and I'm going to say run. And I'm going to use the step function, and we're going to watch what appears in our workspace. So step, I get a file name. Step takes a little while. It loads that file name and gives me Q in millimeters per day for 51 years and other information. Step, for that one site, K = 1, it is giving me months and days corresponding to each one of those dates. Step, it is telling me the locations of October 1st and September 30th, the start and end of our water year. Step, it is telling me how many water years I have in my analysis, 51. All right, now I'm going into the second loop. For the first site, it is getting data for the first water year, 365 values. We do some things with exceedance probability and flow duration curves. And then we extract BFI year for the first site for the first year. Just goes in value 1, 1. We then extract, if you want to, maximum Q for the first site and first year. All right, I'm going to add a second stop sign down here. I'm going to take away my one up top. Again, you don't have to do this. You're just sort of watching and following along with me. And I'm going to say continue. And if this worked correctly, I should have 51 values in the first row for BFI year and max Q. I'm going to hover over here and look at that. I have 1 by 51. 1 is the row, 51 is the columns. I have all of those values. Same thing for max Q, looking good. All right. Now let's check out my trends. I have my years that correspond to BFI and max Q. Oh, it doesn't like that. Sorry, I forgot to add my 1 for polyfit. If you did this correctly on Friday, you already have that. So here's the beautiful thing. I'm just going to say run my code to that point again. All right, there we go. Now I have my slope and my intercept, slope on the left, intercept on the right, for years versus BFI values at my first site. And I am now saving the trend for that first value. Compare this to your work, make sure you get a similar value. I'm going to step a few more times. Why did I get an error? Hold on. Let's look at this. Unrecognized function or variable, B max Q. What did I do wrong? I named it BQ max and B max Q. It's looking for something that doesn't exist. Again, I input my stop sign, I can run my code. And I now have a trend for max Q. All right, I can click continue and it will run for all of my sites. If you have questions, if you run into issues, come see me. You can message me on Google Chat too. I am very happy to help. I'm going to say stop. Over here for trends, the last thing I want to do right now, this is estimating a trend per year. But that number is going to be pretty small. So I'm going to encourage you to multiply by 10 for any of your trends, which will change it from per year to per decade. All right, let's see. I'm going to run this, see if it works. It's computing all the values. Surely, I'm going to pause. It shouldn't take a while to process, but MATLAB will always tell you at the bottom left if it's still working, busy. Oh, and look, it just finished. All right, I want to open BFI year for you. What you should see again is 51 values across 51 columns and 288 rows. The thing that we care about for this analysis are your trends. And here we go. We've got trends. We've got trends in Baseflow Index for all sites. So your goal is to have trends for your metrics that you are interested in by this Wednesday so that we can begin analyzing them. That's the fun and interesting part. The code is how we get there, but the interesting part is saying how is climate change impacting or historically impacting Northeast stream flow. All right, team, good luck. If you have questions, please come see me. I am happy to help. And this is sort of our last big push on code. And then we're moving towards visualizing what is happening. Good job.